So the problem that we are going to solve today is longest increasing subsequence. So the problem statement goes, given an integer array nums, return the length of longest strictly increasing subsequence. So here if we look at the example 1, the longest increasing subsequence we could say is 2 and then 3 and then 7 and then 101. See, the length of this subsequence is 4, which is of the longest length, hence we return the answer 4. Now there's also another sequence that we could see here, which is 2, 3, 7 and then 18, right? So that is also longest increasing subsequence. But the thing is, here we don't care about the numbers themselves, but rather the length is what is needed here. So if we start the sequence with any other number, say for example 10, the other numbers that I could bring into that sequence starting with 10 is either 10, 18 or 10, 101. So in that case, the maximum length I can have is only 2, but we already have a subsequence that is of maximum length 4. So we return the length 4. So let's see how can we solve this problem. So what we will try to do is we'll try to build an increasing subsequence from the list of numbers that we were given. So the first number is 3. Since this is an empty stack, we'll just push it. And then comes 5, right? Now 5, since we are trying to build an increasing subsequence, that means I just have to check what is the previous element and then move forward, right? Alright, so from this example, let's see how we can find the length of longest increasing subsequence. So what we will try to do is, we will try to build an increasing subsequence and then we'll find the length from it. So let's have an array, and now we'll start looping through this given a nums array. Now initially I have my number 3 and then I'll push it, and then comes 5. Now is 5 greater than 3? Yes. So which is why I'll push it. Right? Why am I checking if 5 is greater than 3? Because I'm trying to build an increasing sequence, right? So whatever the number that I'm trying to push, it has to be greater than the last number that is already existing in this array, right? So that's why. And now again comes 6. Now is 6 greater than 5? Yes. So I'll just push 6. Now comes 4. Now what I'll do is, now is firstly, is 4 greater than 6? No, it's not. But I can still form a sequence where 4 is actually part of the sequence, right? So where can I put 4 here? So basically I have to remove one of these numbers and then I have to put 4 in place of that. So what we are trying to follow, the logic is that we'll try to find the numbers that are greater than or equal to 4, so which are 5 and 6 in this case, and I'll take the first element in this and then I'll replace this element with my 4. Okay, good. So now I'll have 4 here. Now we'll move to the next element, which is 2. Now for 2, what are the elements that are greater than 2? 3, 4, 6. Now what is the first element that is greater than 2? 3. So now I try to take out 3 because this is the first element that is greater than 2. Now I'll take out 3 and then I'll put 2, and then again we have 3, right? Now out of these elements, which elements are greater than 3? 4 and 6. Now what is the first element which is greater than 3? 4. So I'll take out 4 and then I'll put 3 again here. So now I have 6. Now I'll 6, I compare it with the last element, which is also 6. So I cannot do anything. So I'll just skip this element. So this way we actually see that we found an increasing sequence and the length is 3. So we return the length 3. But be careful, it's not always that at the end only we will get the longest increasing subsequence. We might actually get it somewhere in the middle as well. So we have to keep track of the length throughout the array looping. Okay, I hope you understood it. Let's get to the coding part. So initially, let's say we have a stack, and then what do? We'll try to loop through the elements that we have. And if my element is empty, if my stack or DP, whatever it is that you want to call, if it is empty, all I have to do is just push the element, right? And if that is not the case, I'll check if my number that I'm currently at, is it greater than the final element in my stack or DP? If that is the case, I can simply push my current element into the DP. If that is not the case, what I'll have to do, I'll have to loop through my DP stack, DP array, and then I'll try to check if my num set I, no, what we're checking, we're trying to find the first element that is greater than or equal to my current element. So let's make it j, because we already have I. Right, now what I'm checking is my element that I'm looping through, is it greater than my num set I? If this is the case, what am I trying to do? I'm trying to put my dpj to be num set I, and then we don't want to do anything, we just want to break it. Right, so at each and every point of time we want to keep track of the maximum length we can have. Right, maximum length will be math.maximum of the maximum length I already have, or my dp.length. So let's initialize this variable max length to be 1. Why? Because in the nums.length, the constraints that we see, it's at least 1. So no matter what the number is, we always have at least one sequence, right? One number is also one subsequence, so which is why we initialize it with 1. And then finally we just return the maximum length. So this is our final code. Let's see if this is what we intended to do. So we initialized an empty array to keep track of increasing elements, and then we assigned a variable to keep track of the maximum length, and then if it is empty, we'll just push the element, and if it is not, we'll check if the element that we are trying to push, is it greater than the last element that we already have. And if it is in the case, say something like we have 3 in our increasing subsequence, and then we have 5. Since 5 is greater than 3, we'll simply push it. And now the else case is that if we have an element that is not actually greater than the last element in our increasing sequence, then we will find the element that is greater than or equal to, not just greater than, but we will find the element that is greater than or equal to, and then replace our element in there. Let's see why is that case. In the previous example, we had until 6, right? Now what if I had after 6 I had 7 and then 6? Now in that case, no, until 6 we have 6, and then when it comes to 7, now since 7 is greater than 6, we'll push 7. And now what do we have? We have 6. Now what am I trying to do? I'm trying to replace the element that is strictly greater than 6. So the first element that we have here, which is strictly greater than 6, is 7. Now if I try to replace my 7 with 6, right? So this is a wrong subsequence, right? Because we cannot have two numbers which are actually equal. We need to have strictly increasing. Now this gives us a wrong length of subsequence. So instead what we are trying to do is, even if the element is strictly equal to, that means we will try to replace it with that element. So 6 is equal to 6. So we'll just replace the 6 with 6, basically doing nothing. So which is why here the equal to is important. Hope you got my point. Let's see if this is working. Yeah, as you can see, this is working fine. Hope you guys liked the video, and if you did, give me a like, and I'll be uploading videos regular basis on weekends. And if you want to receive content, consider subscribing, and hope you have a great day.